Step 8. Speed up the commissioning for the PID controller fine-tuning process. Till the current step, we are still using the simulated process object as our PID controlled object. Even if we are using the simulated process object, but its behavior is similar as our actual process. So that means its response time and the lag time, they are similar as your actual process. But if you are going to control one slow response process, like temperature, water level, or some pressure, it's hard to get that operating point. You might need hundreds minutes or couple hours waiting for this process change, especially to fine-tuning one group PID parameters. We need a couple times change the set point and waiting for the process reach that steady state and then change a new set point. So this couple times changing, we need a long time to wait for the system reaching to its new steady state and do the new change. This comes up one topic: how can we use our simulated process to speed up this commissioning process? Basically, we would have two ways. The first way, that is more general, that is shrinking the interruption code in the PLC or in your controller. Firstly, let's talk about the sample time for our function block. As we know, from this PID controller and our simulated process function block, they all have a sample time. For example, on this PID controller, if we click this configuration window, in this PID parameter page, it shows the sampling time of this PID algorithm. Currently, I'm setting 2 seconds because that is a temperature process. So usually I will use 1 or 2 seconds. That is here. And regarding our simulated process object, that function block, currently this cycle, this time, I also use 2 seconds as a sampling time. The reason why I set 2 seconds, if you recall from the previous step, when we record the online data, I used the 2 seconds as a sample time to record the data. And then I use those record data, import to the Matlab identification toolbox and get the transfer function. So those parameters based on the sample time, that is 2 seconds. So that's why when I implement this function block, I still need to use this 2 seconds as this function block cycle time. So in the Siemens S7-1200 controller, to call the PID controller and call this function block, I use a cyclic interrupt OB. That OB, I set 2 seconds as its period of time. From here, property, cyclic interrupt, I set 2 seconds as its cyclic time. And inside this cyclic interruption OB, I call this simulated function block and code the PID control. If we double click, let's jump to our PID controller. So if we try to speed up this whole commissioning process, we can shrink this cyclic interruption from 2 seconds to maybe 200 milliseconds. That means those time will be shrink 10 times. We will still leave a 2 second setting for the PID and the simulated function block, but to call those two function blocks, we will shrink from 2000 to 200 milliseconds. That's because our model and our algorithm take care the sample time. However, our processor, our PLC, it only take care the cycle time interruption code. It doesn't care what the actual your process value, response time, and response behavior. So we will shrink the interruption code only. So that is the first method, shrink our cyclic interruption code. But keep in mind, because our simulated function block, that theory and algorithm based on the Z transfer, the 2 second sample time on this function block is very important. We cannot change it. Once you change this sample time on this function block, that basically means you change the model of this function block. So this function block cannot represent your actual process anymore. So keep in mind this. The second method, because I'm using the Siemens TIA Portal software, so we can use i7 PLC Sim Advanced, this simulated processor controller, to run our program. We will use one feature from this tool, that is a virtual time scaling function. Like shown in the screen, if I clicked off, that means currently this controller running as our normal scaling. But if I speed up to 20 here, and after I enable this scaling, so that means your controller run 20 times faster than normal. So if the controller run 20 times faster, that means your entire commissioning process will shrink 20 times. Take my processor as an example. Currently, I'm not enable the scaling. The simulated PLC running as a normal. Those two transition times take a couple minutes, both on the increase and decrease process. And now I set the scaling value that is 20, and now I'm going to enable this scaling. And let's see what the behavior of the process. And as we can see, currently I haven't enabled this scaling. So this process is really slow. And now let's enable this scaling. And now I will give a new set point from 42 to 45. Give a new set point. And as we can see here, the simulated process response speed up dramatically. Basically, it speed up 20 times. That's because the ratio value we set 20 there. So I changed the set point from 45 to 42. So we can see this is after the controller speed up. This is a normal standard speed, controller speed. And now that is a scaling with 20 times. So it's very clear to show with this scaling time, the behavior of your process will speed up dramatically. And with this speed up response, you can adjust your PID very quick, because usually to fine-tuning the whole side of the PID parameters, we need a couple cycles or more than 10 cycles to fine-tune the PID parameters. That really take a long time. With this scaling function, it can save us tons of time on waiting the system process response and waiting for the transition time. And more importantly, we can see using this PLC Sim Advanced, we do not need to change the logic and the program. So this speed up operation will not cause any potential program issues. Alright, let's do a quick wrap up. In this video, I introduced two methods to speed up the commissioning process. One way is we set the cyclic interrupt setting. Another way is we use the i7 PLC Sim Advanced. This software set the scaling time and enable that. With this speed up the control system, we can fine-tune our PID parameters. And after we get the perfect PID parameters, we can shift our simulated process object to our actual process object. And in next video, we will switch our process object to our actual process object and test the actual process object control. See you in next video.
Thank you for watching. If you like this video, please give me a thumb up. If you like to watch more videos in my channel, please subscribe. See you in next video.